Moving on to our second section of the unit circle. This is where you can be really lost if you don't pay attention. So I really need you to stay focused during this lesson. Otherwise, you're going to get worked. What's that? How can I explain it? This section alone can just slap you around a little bit, like this. Ah! Like that. I make myself laugh. Okay, 7B number 2, quadrant 1 angles using triangles. What are we writing down? We're writing this down. We're going to have an example. I might even have to have another example there. We're going to do 2 problems based off of this. We have some writing, and then I'm going to show you this and where it comes from. So we have a read. Write this. Okay, so that's the overview of everything that we're doing. Now that you see that, this is on your worksheet. You don't really need to write that down. If you want to do it on your worksheet, you can. So really, I kind of want what's right in between my fingers, right there. Okay? So, substitute teacher, please pause by pressing the enter button now. Coming back to you. What this says is that we're going to be using these 30, 60, 90 degree triangles, the special right triangles from 7A.2. That means the last unit, section 2. If you need review on that, we have it in the archives. You have your notes, and I have it on the website, and I have the video on it recorded on YouTube if you ever need to see it again. So we're going to take this 30, 60, 90 degree shortcut and the 45, 45, 90 degree shortcut, and we're going to be dealing with trig and SOHCAHTOA on those 2 things. Let me show you how it works. Here we go. This is on your worksheet. If you want to do this problem on your worksheet, feel free to switch over to your packet. Whoa. First thing it says for me to do, label the sides in terms of S. We learned shortcuts last time. What were the shortcuts? Across from the 30 was S. Across from the 90, hopefully you remember, was? Say it out loud. I hope you said 2S. I don't know what I did. Come on, pen. There we go. S, 2S. Across from the 60 was S root 3. S, 2S, S root 3. If you don't remember that, you may need to go back and visit the 7A.2 notes, just in case. So we've done this, label the sides in terms of S, and then what it says is, what's the sine of 60 degrees? And so what it's asking you to do is to take this generic triangle and find the opposite over the hypotenuse of 60 degrees. Which angle are we using? We're using 60 degrees. We're using this angle. Which one is our opposite of 60 degrees? Which one's our hypotenuse of 60 degrees? If I'm using sine, I'm using SO of SOHCAHTOA. The O over the H. The S root 3 over the 2S. That's what it is. So when I ask you to find the sine of 60 degrees, if I'm using a shortcut to do this, it's going to be in terms of s, but watch what happens when I'm dealing with this problem. S divided by s. That's multiplying. We can reduce, can't we? Does s go into s? So the sine of 60 degrees, the sine of any triangle, the sine of 60 degrees of any triangle is going to be in the ratio of root 3 over 2. Think about it. If this side was 5, and this side was 10, and this side was 5 root 3, it doesn't matter. Let me write that down. 5 root 3 over 10. Guess what? It doesn't matter. It will always have the same ratio as root 3 over 2. No matter which side you had, if we had numbers in there, it would always reduce to root 3 over 2. The sine of 60 degrees is always root 3 over 2. Every single time. And that's a big concept because look at how we're doing this. We're dealing with variables, with things that could be anything. That s could be anything. So that would double that anything, and then that would be that anything times root 3. If you reduce it with the anythings, it will still always reduce to that radical. That's a huge concept. If you understand that, the rest of this worksheet will become easier to you as we do it. Let's reduce the tangent of 60 degrees. Here's 60. Tangent. SOHCAHTOA. I need the A. I need TOA. So what do we write? S root 3. That's your O. What's your A? And then we see if it reduces. Does s go into s? Those are both coefficients. They're both outside the radical. They can reduce, which is root 3. The tangent of 60 is always going to reduce to root 3 no matter what for any triangle, which is why your calculator knows what to do when you press the tangent of 60 degrees. It gives you a ratio. Guess what that ratio is? Root 3. Matter of fact, every time I press it, it knows. Doesn't matter what the triangle is. Your ratio will always be about 1.732 times bigger for the opposite over the adjacent. That's what it's saying. So if you see how to do this, I am hoping you're going to be able to do those first 13 problems on your worksheet. You might have to do the same thing for a 45, 45, 90 degree triangle. You'll need a shortcut for that. And then when you're asked for the sine of 45 degrees and you have to do the opposite of hypotenuse, you should be able to reduce things down to what it's going to reduce to. You'll see. And don't forget to rationalize on these ones as well. Make sense? So let's do this. Just because I didn't write it down, but I want to have it here just in case. We have an S. And then across from the 90 is s root 2, and we should have a s root 2. Like I said before, if you need to go back to the notes, go back to them. So the sine of 45 is equal to the opposite over hypotenuse. The opposite over the hypotenuse. Coefficient goes into it one time, 1 over root 2. That is not rationalized. You need to rationalize it, please, for right now. Root 2 times root 2. So the sine of 45, square root of 4 is 2. The sine of 45 degrees will always reduce to root 2 over 2. That just gives you one more example of how to do it. Okay, moving on. That brings us to this whole unit circle thing. You guys, I'm not going to show you the whole unit circle. We'll get to the whole unit circle by the time we get to worksheet 5. But for right now, because we've done some of these trig functions with the triangles, it relates to part of the unit circle so you can see it. What I want you to do, we're going to pause this video here in just a moment, but let me make sure everything's on the screen that I want you to have written down. We have this. It might benefit you to have this in your notes. It is on your worksheet though, so I don't need that right now. We can do the worksheet together. Let's make sure we have this for right now. Substitute teacher, allow the students to write this down, and you can pause the video by pressing enter now. Coming back to you. The unit circle has a radius of 1. That's going to make a difference to us. If you saw that there's a third triangle that you're going to use on this worksheet, and it has these things that you'll see that there's an x over r and a y over r and a y over x when you're dealing with a theta and you have an x, y, and an r. What I like about this is that you have an x distance, a y distance, and a radius. And that's really what we have for a circle. We have a x-axis, we have a y-axis, and then we have this thing called a radius. So we're going to be using these things to fill out this particular unit circle. So here's what we're going to do. On your worksheet, if you want, what I want you to do is you can do this with me, and I'm fine with it. How many degrees if you have a terminal ray? Let's do that. Let's go from here to here. Right about there. If I have that, how many degrees are we going? That is 0 degrees. If I go up here, how many degrees is that going to be? That is 30 degrees. If I have to go up to here, that is 45 degrees. That's 60 degrees. And then this one over here will be 90 degrees. That's what we're filling in for right now. We're going to kind of ignore 15 and we're going to ignore 75 because those aren't really important. But what are important are these ones, because these ones we use all the time with the unit circle. And what this is with this unit circle is we're looking at what are the ratios for a 30-degree angle or a 45-degree angle or a 60-degree angle or a 90-degree angle. And we're going to be dealing with cosine, sine, and tangent. If I were to drop this down from here straight down to the x-axis, then I would have a reference angle of 30 degrees right there. And I would have a perfect right angle right there. And guess what we have? We have a 30, 60, 90-degree triangle. What's important about that is this. If I know that this is a radius of 1, and that's a radius of 1, and that's a radius of 1, and that's a radius of 1, we can start figuring out some of these coordinates. For example, if I know that this is a radius of 1, and this is a radius of 1, and this is a radius of 1, and this is a radius of 1, I know that the coordinate of this is 0, 1. Your x coordinate, you went 0 to the left or right, and you went up 1 unit because the radius was 1 unit. If I go all the way out here to this coordinate right there, I've went 1 unit to the right and 0 up, so it's 1, 0. That's the ordered pair for 0 degrees. That's the ordered pair for 90 degrees. Now, we said that this is a radius of 1 and this is a radius of 1. We have a 30, 60, 90. Let's do that shortcut that we had before. Let's do across from the 30 is S. Across from the 90 is 2S. Across from the 60 is S root 3. Let's figure out what the x coordinate is and what the y coordinate is so we can know what this location is at that top for this x distance, for that y distance, for a 30-degree angle. 30-degree angle, x distance, 2s. This is what's given. I know the radius. The radius is 1, and that's on the 2s side. If I want to know what s is, I have to divide by 2. So s has to be equal to 1/2. What does that mean y is here? Guess what that means? That means the y coordinate of this point is 1/2. Put that in on your unit circle. If this is what s is and you have to plug it in here next to the x, then what we have is 1/2 times root 3 is the same thing as 1/2 times root 3 is root 3 on top and 2 on bottom. The x coordinate is root 3/2. That's our x coordinate, root 3/2. Let me zoom in so you can see that. Root 3/2. The x coordinate is root 3/2. The y coordinate is 1/2. Where does it come from? It comes from this radius is a 1, 30, 60, 90, s, 2s, s root 3. That's what goes there. Now let me show you something kind of neat about it. Well, no, I'm not going to show you something quite neat about it right now. I'm going to erase some things. Put that back there. Okay. So if I were to do the same exact thing, except now I use the 45-degree angle, which is right there. Then I know the formula is s root 2. And I can find this x distance for that x coordinate, and I can find this y distance for that y coordinate. And hopefully you know that these two are going to be the same. These two are going to be the same. So if I know that this is a radius of 1 and it's right there, so 1 is the same thing as s root 2, could we figure out what s is really quick? It's 1/√2, but is that rationalized? Nope, let's rationalize it. What does that mean? That means if this is the s root 2 side, then s's distance has to be root 2/2, and the other one has to be root 2/2. That's your x coordinate. That's your y coordinate. We're almost done. We only need one more set of coordinates from these triangles. Going kind of fast. But let me just give you a chance to talk about what I am doing. If you are stuck or confused, now is a good time for the substitute teacher to press pause, and you can ask the person you're sitting next to for help, or if they don't understand, ask the people in front of you or behind you. Let's give them a moment to discuss. Please press enter now. The last triangle is this one. That angle here is 60 degrees. That's what that means, 60 degrees. That means this angle must be 30 if I drop it down. And this is our x distance, and this is going to be our y distance right there. So if I'm trying to figure things out, I'm going to go across from the 30 is s, across from the 90 is 2s, and across from the 60 is s root 3. That's supposed to be an s. What am I given? The radius is equal to 1. 1 is equal to the 2s side. 1 is equal to the 2s. So what does that mean s is equal to? S has to be equal to 1/2. What does that mean my x coordinate has to be? Plug that 1/2 in, and then it multiplies by root 3. So what does that mean my y coordinate has to be? And so what we have here, let me erase some things. I'm hoping you saw how I did that. I'm hoping this is all making sense to you. Well, we have our coordinates. We have angles. That is the essence of this corner of the unit circle. It has for every angle what the ratio will be for a single unit if the radius was 1. That's what it is. So what I want to do now that you have that, we need to talk about how we're going to apply it and where it comes from. So let's read this and let's show you something. Earlier, you had a triangle problem on your worksheet. It's the third one. I'm hoping you've done it. If you haven't, this is what you should have figured out. If I took this equation, I multiply both sides by r, would you get r cosine theta is equal to x? And if you were to take the sine theta is equal to y over r, and you were to multiply by r and by r, the r's would go away. You'd have r sine of theta is equal to y. Earlier, we said that the tangent of theta was equal to y over x. And right now, I just showed you that x is the same thing as r cosine theta. And y is the same thing as r sine theta, which means that the tangent of theta is y over x. It's also r sine theta over r cosine theta. Couldn't we then just do this? Yes, we can. Therefore, the tangent of theta is the same thing or is equal to the sine of theta divided by the cosine of theta. It will be very beneficial if you memorize that the tangent of theta is the same thing as the sine of theta divided by the cosine of theta, and I'll explain why later. The last thing we're writing down is this section right here. And then I'm going to explain what we're doing and how we're doing it. And we're just going to do some things. This will set us up for the 5th worksheet way better than what I've been doing. So let's give this a go. Substitute teacher, please press pause now while students write this down. And coming back to you, since the unit circle uses a radius of 1, we can simplify cosine of theta is equal to x over r to, if I plugged in 1, x divided by 1 is still x. And sine of theta is equal to y over r. If r was 1, y divided by 1 is y. So I can think of the cosines of the angles as the x values on the unit circle, and I can think of the y values of the angles as the sine. Cosine is going to represent our x values, and sine is going to represent our y values. I need to say that one more time so you really get what I'm talking about. Because the cosine of any angle is the x-coordinate divided by the radius, our cosine is always going to represent our x values, our x-coordinates. Our x-coordinates are always going to be our cosine values on the unit circle. Our y values are all going to be the sine of those angles, That's the sine. That's the cosine. Cosine, sine, cosine, sine, cosine, sine, cosine, sine, cosine, sine. I'm hoping that makes sense to you. And then, because we know that the tangent of theta is the same thing as sine divided by cosine, if I want to know what the tangent is of any of these things, I can do the sine divided by the cosine. The sine divided by the cosine. The sine divided by the cosine. The y divided by the x. The x is on bottom, then the y would be on top. That's the tangent. That's the big idea. We can now use this to find any ratio we want from 0 to 90 degrees as long as it's using one of these 5 reference angles. So, here are our last 2 problems. The cosine of 90 degrees. You can't really draw a triangle with the cosine of 90 degrees. But what we can do is we can know that the cosine of any angle is equal to the x-coordinate over the radius. In our unit circle, the one we just wrote down, here's 90 degrees. What was the radius again? I'm hoping you said 1. We're trying to figure out what the x-coordinate is. 90 degrees. What's our x-coordinate up here? If you said 0, you're absolutely correct. What is 0 divided by 1? So the cosine of 90 degrees is 0. And that's how we're going to use this unit circle to answer our questions. We're going to look at x-coordinates for cosine and y-coordinates for sine. Now, I know that I could show you this on the calculator. And there's part of me that doesn't want to show it to you because if I press cosine of 90, I get 0. You are not going to be allowed to use the calculator. You're going to have to know how to do this with the unit circle. So get it into your heads right now that the cosine is dealing with your x and the sine is dealing with your y, and you're going to be golden. But what about tangent? Tangent will be the sine divided by the cosine. All I have to do now is do the sine of 90 degrees divided by the cosine of 90 degrees. Why did I use 90 there instead of theta and theta? Because it gives me what theta is. What does that mean? I just find the y value of 90 degrees. What is the y value? What is the x value while we're here? I hope you know it's 1 over 0. Now this means 1 divided by 0, but guess what that is? That is undefined, because you can't divide by 0. Technically, there's an asymptote here, which we'll talk about way down the road next year. You'll see that in Math 3 Honors, but not yet. Anytime you divide by 0, it is undefined. There's always a possibility of dividing by 0 with tangent because there's a denominator, whereas the other ones don't have that. Sine and cosine don't. Okie dokie. So hopefully that makes sense to you. Watch this video again if you need to. Otherwise, you have the rest of the time to work on your homework.